Okay. So this is a class on polynomials, right? So polynomials, and what we are going to do, let me state the name of the topic clearly this time. We sort of were moving towards this over time gradually, but let me now call this what it's called in the literature, Lagrange interpolation. Okay. Could anybody give me a brief idea of what this is about, or just a brief summary of what we were trying to do last time? What was the main goal of what we were trying to do last time? I think Ishana and Aparna, you two were certainly there. I don't remember if Satya was not there. Pragdish, I don't remember. I think he was also not there. So two of you, those who were there especially, and if others have also seen, what was our goal? So yes, exactly. So we are trying to find the entire polynomial, okay, using few points, few random points that are given to us, right? So let's say that P is so it's all about determining the polynomial. That's one way to view it. So Px uh, be a polynomial. So this will do it. We'll do this gradually. Polynomial of degree less than or equal to. So now I'm putting less than or equal to. I'm not calling it equal to. I'm just calling it less than or equal to 3, such that. So to begin with, let's keep it basic. P of 1 is 1. P of 2 is 5. Yeah. So polynomial, so at the point 1, it takes the value 1. At the point 2, it takes the value 5, and so on. Okay. What I'm trying to say is that there is no pattern in these numbers. Kind of. I mean, one can make that proper, but the point is there is no pattern. So what the goal here is to find Ex, right? So so before, okay, let's say before we try to find Px, can you tell me why Px has to be unique? Can any one of you explain why? Okay, I want to unique. Why is there at most one such polynomial? This is also something that we have talked about earlier, but why is there at most one such polynomial? And when we find it, then it will be exactly one. Anyone? Let's answer this second question first. It's more qualitative. Why? What happened? Anyone? Any? More details. More details. You're in the. I mean, that's right. It has to do with the degree. But so why, if the degree is not more than 3, then why are 4 points going to determine a unique polynomial? Why can't we have 2 polynomials? Any more reasons? So this is sort of an algebraic question, right? You will have to understand that this is a polynomial. So, so come on, anyone wants to give more reason? Anything? Well, maybe a slightly better answer would be okay. Let me just say it like this. I mean, can anyone give an explanation based on equations you'll have to form, or maybe number of coefficients? Yeah. Okay. So, so one way is that, well, Px is a 3-degree polynomial, so it will have at most 4 coefficients. Okay? At most 3 degrees, so at most 4 coefficients. So I mean, this would be a 3, right? And then there is this, right? And now, if you are going to use these equations, then what kind of thing do you have? So there are 4 things which you have to find out, right? This is not a very good explanation. I mean, in my opinion, there's a better explanation, but I want to, because some of you have tried to solve this question in this way, this first question. So you should have an idea based on that, an explanation based on that, as to why it's, at least you are sure that you cannot get 2 polynomials, right? So this is one, right? And similarly, so how many equations are we having here? How many equations do we have? Are we going to 4 equations? Yeah. So there are 4 equations and there are 4 variables. So well, that by itself doesn't mean that you cannot have more than one solution, but at least it makes it more plausible that there should not be more than one solution. It is still possible that there is more than one solution, but okay. But really, I expected that someone can give an explanation based on roots, based on the zeros. Anyone? So maybe can you give an explanation based on the roots? What do we know about the roots? Well, if it's a 3-degree polynomial, then it will have at most 3 roots. So let's say it has 3 roots for the moment. So we cannot have 4 points where it is 0. Right? The degree, unless it's a 0 polynomial. So based on that, could you say why there should be a unique polynomial? What if there were 2 polynomials? So if there is a q also, such that q of 1 is 1, q of 2 is 5. So basically, this uniqueness, we are shifting that, we're sort of explaining that through the zeros. The restriction on zeros will give us a restriction on the polynomials. What if there was one more polynomial? Then what could you say? How do you, so let's think like this. How do you bring, forget about the question, okay? I mean, how do you bring in roots into the picture from here? Given that there is P and there is Q, how do you bring in roots in the picture? How do you bring zeros in the picture? So how do you, so if you have two polynomials, look at P and look at Q, P1 is equal to 1, Q1 is equal to 1, P2 and Q2 are equal, P3 and Q3 are equal. How do you bring in zeros? What is the natural way to bring in zeros? So we know that the degree is at most 3, right? Means it doesn't have to be 3, but it's not more than 3. Well, I mean, I understand that roughly it's clear. Like Ishana has given a reason, and also I suppose, yeah, it's makes sense that yeah, there shouldn't be from the equations perspective also. But again, that's those are not proofs, right? Because how do you know that a four equations, four variables cannot have more than one solution? It might have. I mean, one can make examples actually. But that aside, how do you bring in roots into the picture? So, well, let me suggest something. How about you consider the polynomial px minus qx? What happens if you consider px minus qx? What can you say about this polynomial? This is also a polynomial, right? I'm just naming it hx. You may or may not use that name. You can just call it px minus qx. What can you say about px minus qx? Why is it 0? So why is it 0? That's what we want. That's what we're expecting. That's what we want to show, that P and Q are exactly same. And so Px and Qx are 0 as a polynomial. It's 0 at every value. It's all the coefficients are 0. All those things are same. So is there a reason why it should be 0? What will happen? Right. So then, so h of 1 is so what? So why? I mean, yeah, it's a trivial. It may be a trivial fact, but still, why is it? So if it is 0 at 4 values, then why is it 0 at every value? What do you say to like, convince that? Yeah. Answer, okay, answer of what? I mean, eh, no, I mean, why? I mean, so why can P5 minus Q5 not be 0? I mean, just so that's what we are somewhat we are trying to prove that, right? But yeah, you have reduced the problem to roots, right? That you have now have a 3-degree polynomial which has 4 roots, or at most 3-degree polynomial which has 4 roots. So what can you say about that polynomial? Yes, yeah, so it's at most 3-degree and it has 4 roots, so it has to be the 0 polynomial. That's what you have to say, right? So it's because it cannot have 4 roots. That is the basic fact that we had in the beginning, right? That a n 100-degree polynomial cannot have 101 roots. Okay. So this was not difficult, but yes, okay. I mean, it's just that you have to start reasoning these things, and the more you try to say and think and write these things, this is how you get comfortable. Okay? But is this clear to everyone? Not just the fact, but also the method that we are using. Yeah. So you see, right. Initially, we had this very basic fact that if you have a 3-degree polynomial, it cannot vanish at 4 points. Okay. If you don't remember the proof of that, try to do it. Otherwise, that's fine. For now, just maybe assume it if you, in case. Okay. Because, so anyways, so a 3-degree polynomial cannot have 4 roots. That was the premise that we started with. And that was how we were first asking some questions. 1 or 2 classes, we did that sort of things. So basically what, I mean, 3-degree polynomial cannot have 4 roots. What kind of thing is that? That if h1, h2, h3, I mean, sorry, this h of 1, h of 2, h of 3, h of 4 is equal to 0, means it matches with the 0 polynomial, all right? Then h is also 0. Yeah. Even there, if you think, it's sort of saying that there is a unique polynomial. That means 0 is the only polynomial. You see, in a way, that was a statement already there, right? That h cannot be a different polynomial and h has to be 0. So there also we had this statement. Yeah? But it was in a much simpler situation where it was 0. Now we are coming to now we are coming to again 4 inputs, and we are asking if there are 2 different polynomials. Now the outputs are not 0. Earlier the outputs were 0, so it was slightly simpler or whatever. It's sort of not simpler, it's equal, as you can see. Okay. So now basically that question has translated to a place which is not 0. Earlier, the question was at 0. These 4 values, it is 0, show that it is 0. Or show that it matches, it has to be the 0 polynomial. Now, basically, there are 4 values where it takes some outputs, show that there cannot be 2 of them. Okay, so how do you prove something? You translate the question to 0. And translating the question means consider P minus Q. This translating the question is you're using the subtraction property of the real numbers or whatever, just now your number system, is the key. Otherwise, the question is not simple. Otherwise, it becomes complicated, right? So you see this extra thing, the subtraction that you have, you're using it to your benefit to translate this question to 0. And so you consider P minus Q, the question translates to something that you have already done. This is a very, very common feature. Okay, that's why subtraction is such an important operation to have. Okay. So we understand that we cannot have 2. Okay. So please think about this once more. Okay. But now we come to the question of finding. How do you find the one that is there, if there is one? So again, let me tell you that I'm saying at most 3. I'm not saying 3-degree, because what you may find may end up being a 2-degree polynomial. I'm not guaranteeing that it won't be. Yes, so take us through that, please. That's because that I want to see. This will be interesting. So maybe these are not, what I'll maybe do is make the boxes like this, right? We'll have more space. We'll need more space. So, okay. Four boxes. Okay. Okay. In what way you put 5? You multiply? Okay. Yeah, so this is also, I'm not writing it in a, I mean, I'm okay. Let me just give me a second. I have to just shift a little upwards. X minus 1, 5. Okay. And what do you do about the rest? Okay. One second. X minus 2 into minus 1. So y minus 1? Y minus 1? Okay. Okay. Oh, hold on. So is the situation till p of 2 fine? So now other people, everybody else, just first see. So is p of 1, so what is my polynomial, right? My polynomial is this polynomial, which so far is just this small thing, and this plus this, plus this, plus this, right? So it's a big polynomial, but it sort of has a compartmentalized, and it has a mean, those compartments have meanings, but so far, is p of 1, 1, if this is your sum is your polynomial? Yes, p of 1 is 1. Right? You can check it because this gives you 0, this gives you 0, this gives you 0. That's the purpose of x minus 1. And the first one gives you 1. Is p of 2 5? It is 5. That's correct. Good. So that's good. So I understand that now you can do it. Very good. So you have understood this. Okay. So anyone now I want someone else to build on this and try to. So building on this only, because sort of we have only one method so far. So I'm not expecting that you have some different method. But from here, uh, can you build on to fit to have 3 also give you 7? Oh, yes. So basically, see, initially the 1 is fine, right? The 1 was there. But then when you put the value, you have now, so initially there was just the 1, right? But then you put x minus 2, that's mandatory. But then what does it mean? It means that when you put x minus 2 there, then when you input 1, it will have an effect, right? The x minus 2 will have an effect, right? When you put in 1 here, it will give you minus 1. So in order to nullify that, you have to do this. Right. So initially this compartment was only 1. There was no problem. But then you put in the x minus 2. Why do you put in the x minus 2? So that it becomes 0 at 2. But the moment you do that, you should normalize it. Otherwise, the 1 at 1, it will become something else, in this case minus 1. So you should do this. Here also you should be doing 2 minus 1, but 2 minus 1 is just 1. Because here at 2, it will give you 5. But then when you put in 2 here, it's 2 minus 1. So you need to nullify it by dividing by 2 minus 1. But that's just 1, so it doesn't matter. Okay. So tell me if this is clear. So is it okay now? Or if you want, we can do it from the beginning once again. Yes. So Aparna, is it okay? You understand? Okay. So then let's see. Try to do for 3. For the third, how do you adjust adjust these polynomials, these monomials? You know what it means, right? The monomials is, you study the definition. So that at 3 it becomes 7. Right? You want it to become 7 at 3. So when 3 comes in, what would you want the first compartment to do? Nothing. You want it to vanish, right? When 3 comes in, you want the first compartment, the first monomial to switch off. And how do you switch it off? You can't just say multiply it by 0, otherwise it will always be switched off. You don't want that. At 3, you should switch it off, which means because for 3, the third compartment is responsible. Okay. So for 3, you switch it off. But then when you do this, then you realize that now when you input 1, the x minus 3 would have an effect. So you nullify that by saying 1 minus 3. Now you can relax. There's no problem. At the other values. I mean, at the value of 1, not the other values, but just at that value for which the compartment is made. Okay. You normalize that. And well, do the same thing in this also, right? So it's very formulaic. I mean, there's a very straightforward thing. It's not there is a trick you could say, but then that sort of is just that's the only thing that is there, one thing. And then there is just normal. Again, you just normalize it so that at 2, you don't want this 2 minus 3 minus 1 to come in. So you just make sure that. So this should be 2, obviously. Because at 2, you care about the second compartment, right? That at 2, it should give you 5 and nothing else. Okay. And well, this is just, this is at 3, this should be 7. So let's just do it. All right. But obviously, so at 3, this should give you 7, which means that, but when you put in 3, then this x minus 1 will give you 3 minus 1. So you want to again nullify all that. You see? So as a rule, you should have done it right. One should do it right at the beginning. But okay, one sees the need of it now. But you understand now, it's just a pattern to it. You don't have to think every time. That's why we are doing this. And then we have this x minus 3. Yeah, x minus 3. So that it gets switched off. Okay. I mean, ideally, again, you should again divide this by 4 minus 3, but you will realize the need of that later, and so whatever. Okay. Now you can check that at 3, this whole thing gives you 7. Because the first 3 compartments get turned off, and this third one, the first 2 and the last one get turned off, and at 3, the third one gives you 7. You input, you see. And similarly for 4 also you can. So maybe someone can tell me for 4, how do you exactly do it? Yeah, maybe Aparna, you can try. So if Satya and Pragdish, if you also. What should you do for 4? I mean, what should you do means you just repeat the same thing, but yeah, it's a new thing. So we are trying to see exactly what you have to do. So we will practice this a little bit. I mean, we'll do a few more examples, maybe, yeah, maybe today or next day, we'll see. Today I don't want to, I won't make it late. It's become a bad habit of mine. I'll start on time from next time and on time. But what do you do for 4? That is important. So you want P of 4 to become 15, right? So what should you do in the first compartment? That certainly, right? So when you multiply it by x minus 4, should you divide by something also? Yeah, just based on the pattern, you can say that. And also the reason, so that when you input 1, it remains 1. So that this remains 1 at 1. Right? When you put x equal to 1, it remains 1. That also has to be ensured. That's it. Now what about the second, third, and fourth? Right? So now it is just the same things. X minus 4 by 2 minus 4. And similarly, yeah, this is x minus 4 by 3 minus 4. And this is just 15. But then you notice that when you put in 15, then at 4, there's this. When you put in 4 in the last compartment, this gives you 3. Don't want that 3. You remove it. 4 minus 1. Don't want the 2. 4 minus 2. Well, the last one is a 1, so it does not matter. But just for the sake of a formula, otherwise, for example, your computer may get confused. Yeah, the formula. If you're putting this in the computer formula, right, sort of, you have to, or even just for the sake of formula, it should match the form. The exact numbers are not important. So you always maintain the form. Yeah, so even here, I'll just put in 2 minus 1. That's it. This one just works. It has to work. It's a beautiful construction, right? This Lagrange interpolation is so nice. Yeah, the idea is so simple, but it is a very nice formula. And I think I will leave it at this formula. I will at this form. I'm not going to, I don't want to just give a formula, given 10 endpoints and this is a formula. I could say that you can also just Google and find that will be the first thing you'll find. Big formula. I don't think it is important. This is what you have to really know. And the formula is not difficult now, right? I mean, you understand. So the rest of the points you have to put in here, right? X minus the rest of the points, x 2, 3, 4, whatever, right? And similar. Okay. So that's all that it is. It's very, very simple. If you think about it, it's not difficult. Yes. This is the polynomial. Is this not a polynomial? Oh, so you want to expand it? You can do that. That is not interesting. In the sense, this is the polynomial, right? Okay, so you want to say that you want to maybe you are saying that you want to write it in terms of x cube, x square, and so on. Yeah, but yeah, that's the point. I mean, so that is really that is difficult. In the sense, if you are looking for these coefficients, right? That's what you're saying. You're looking for these coefficients. Not easy. They don't have a good form. And you don't even expect. I mean, if you give me some random values, why do you expect it to have a good form? Right? So all I can say is just expand, and if that's really in the question, you expand it and you find the coefficients. Okay. Here that is not that will not give a good answer. Okay. So basically, this brings us to another point, that when we say that we are looking for a polynomial, what do we really mean? Right? That's a So if you're saying a polynomial, you write a polynomial using these basic polynomials, x square, x cube, x square, x, or just the constant number 1. Let's say 3 degree, at most 3 degree. And we usually write the polynomial like this. Yeah. But here is the question. I mean, is it always best to write a polynomial in that way? No, right? Suppose I tell you that P is a polynomial such that P of 1, 2, 3 is 0. Then what's a good way to write that polynomial? I mean, you can still write it like that, but then no doubt it's better to write the polynomial like this for a lot of reasons. Does everybody agree to this? Right? If I tell you that P is a polynomial which, P of 1 is 0, P of 2 is 0, P of 3 is 0, it's a 3-degree polynomial. Then you will say this. I mean, the A naught you don't know, or AN you can call it A3. It doesn't really matter, right? You don't know that, but that's fine. But still, this is a better way to write the polynomial than expanding it. Is it? Yeah, is it making sense to everyone? You see, so how you write a polynomial, right? What do you use to write a polynomial? Really up to you. It's really dependent on the situation. Okay. The point is that you want to use those blocks, and this is a very interesting point. You want to use those blocks to write your polynomials so that the coefficients become nice. I mean, if all the roots is given, then that's the best situation. You don't even have to worry about any coefficients. Sort of everything is just there. Okay. But for example, in our situation, now these are little abstract points. Okay, but I just want to tell you this, and because this is really the topic of polynomials later. Okay? That what should you use to write a polynomial? What coordinate system, what basis, what number base should you use to write that number? Should you go for base 10? Sometimes base 3 may show you some new pattern in the number, which base 10 digits don't show you. It is something like that. Like, for example, in this situation, given this information, given the value at 1, 2, 3, and 4, whatever the values are, that's not the point. But given that the values are given at 1, 2, 3, and 4, it seems like to write a polynomial using these blocks. This is one block. This is another block, and you understand what these blocks are. These blocks are completely dependent on those things. You don't want to put words into this, they are product except for one and so on. But you can understand, without words, you can understand that these blocks are sort of directly related, easily related from the question, right? Now you would agree that using these blocks is certainly much better in this situation, because the coefficients, when you use these blocks, then the coefficient, this is the coefficient in this case, or the coordinate, you see, it's really nice. It's really, really nice. I'm not saying you have to calculate this number, but it's really directly from the question that these numbers come. 1 minus 2, 1 minus 3, 1 minus 4, 2 minus 1, 2 minus 3, 2 minus 4. These numbers are directly from the question. Or they mean you can directly read off the polynomial's property from this, relevant to this context, right? The 5, you know what that means, the 7, right? So in this situation, using these blocks is sort of the best, is good. In some situation, some factored form is good. In some situation, this is good. Some situations are different. These are called bases of a polynomial. There are many different coordinate systems. Okay, which one is suitable in which situation? That is really the art which you have to pick up from the situation. Okay, so I mean, for example, if let's say that you are in the 2D plane, right? Let's say that there is this point which is sort of 5 steps to the right and maybe 3 steps up. Okay, if someone is here and let's say, I mean, you are here and someone else comes along, yeah, some other person comes along, some X comes along and asks you, I mean, how do I get to this point S? What would you say? What's the easiest way to translate that information? You would just say walk 5 steps right and 3 steps up. right? That's the easiest in this situation, right, to say. So it's just 5 comma 3. Okay, but for example, if the situation is on a circle, right, and you know that the point is on the circle, right, let's say radius 1. So again, someone is here, and or maybe you are all on the circle, some we are all here, and someone asks you how to get to maybe this point. Okay, if this angle is 60 degrees, it is not a bad idea to tell him that sort of rotate 60 degrees sort of. Hey, what I'm trying to say is that 60-degree is easier, is more easily translates the same information. Otherwise, you could tell him, that you sort of, I don't know, walk this height. You have to find this height using Pythagoras, some square root, something square root 3/2, right? Sorry, and then walk some again square root something many steps to the left or something. I mean, that's also fine. You can say that, but just saying that degrees in that situation is easier. So in that situation, the coordinate system of degrees is better. Okay, where is this point? Or this point is 120 degrees. This point is this many degrees. Okay, so it really depends on the situation. How do you study the system? Like in physics and volume questions also, you would have seen, we take some system, we sometimes section it vertically, sometimes horizontally, depending on what helps to understand. So it's just nothing. Yeah, so that's fine, right? And that's all it is. Different coordinate systems for different situations. Okay. Uh, let me so we don't have time, so we will do this next day, but let me just give this as a homework. Okay, so suppose this is not difficult. Okay, this is not difficult, and it's just a computation exercise. It's nothing. So let's say that I give you this polynomial. So it's just a random polynomial that I'm giving. Yeah, polynomial, and I tell you, can you now help me to write this polynomial using not x but x minus 1? Is it, so first of all, I mean, is it possible? And if it is possible, then please find me the coefficients. In this new coordinate system, new way to write polynomials, what will be the coefficients? Sorry for the color, this thing. Yeah, no, so I did not drink water after eating, that's why. So yeah, well, this is fine. And then this is, and basically I want you to find this, this thing. You understand, right? The same polynomial I'm writing like this. Those two are the same. It means that if you expand this, it will be that polynomial only. So what will the coefficients be? How do you find it? Okay, so the coefficients could be what? I don't know, A, B, C. You have to find these. Is the question making sense? Or is it not making sense? Yeah? Like, for example, I mean, if you have just x, right, and I tell you to write it in terms of x minus 1, then, I mean, it will be this. Right? Just one more example, right? If I tell you to write this is easy. This is 2 degree and it's just straightforward. So I'm just doing this. The hard one you can do. This, and now you see the coefficients are, now the coefficients are 1, 2, and 1. Earlier it was only 1. So, just trust shifting. Now, how do you do for this complicated case? I don't know, but they do in a complicated way. Can you find a simple way? Think. One more question. So I'm just now getting into this, that these are actually possible. This comes from what Aparna asked, right? So I'm just trying to extend that. And this is a very interesting topic of writing a polynomial in different bases. That is the polynomial given? What is the polynomial? Initially, I defined the polynomial like this. And but then you're writing the polynomial in different ways. Okay. That's also a good question. That's a very important question. That is a very important question, and that basically is sort of, in a way, is that 4-dimension space may, you take any 4 points in different, any 4 lines in different directions, using them you can get the whole space. That question is that, and we will try to see it not maybe like that, but in a different way, that it is unique. Yes, it is unique. Why it is unique? That has a very interesting and very general reason. But obviously we'll say it in a, that's right. No, that's right. And then maybe do this, and again, is it unique? And can you find it? And is it unique? All kinds of questions can be asked. It's a very, uh, you know, but to do it, you can just do the boring calculations and do it also. But you should do it. Okay, you can do it in the calculation way. That's not at all a problem. Okay, uh, but you should do it because you can all do this. If you expand it, spend time, you can calculate and find. But there are good ways, division algorithm, something to see. I'm not changing the color. This is just that. This is the last thing. Note this down, okay? And try this. So I'm giving this because this doesn't really need much on the interpolation. We'll do one more example on interpolation next time so that we get more comfortable. We need that. Uh, but yeah, and the one. Now you see, this is another interesting basis, another interesting way to write the polynomial using this sort of, sort of rising factors, rising 1, x minus 1, x minus 1, x minus 2, x minus x minus 1, x minus 2, x minus 3. Sort of this is the factorial sort of thing. Think. Yeah? So if I find the coefficients and then uniqueness and so on. Okay, this is it. Note it down. This is it for the class. And once again, I'll upload this if you need to see it. More importantly, ask me any questions if you need to. Okay, it's all in one place in the playlist polynomials. Just search it. Yeah. Okay. Please review this. Go over this. Spend some time on it. I mean, even if it feels a little boring in the beginning, just when you're feeling a little free, just do it. Okay. Eventually, when you get to understand, not eventually, just if you just spend more time on it, it will reveal more of its. That's the nature of these things. These are not exciting immediately. Okay, a little bit sometimes you may have to put in. Okay, that's it. I just note it down, and then after that you can leave. Okay. Okay, then thank you. Bye. Good night. Yeah, yeah. Good night.